Hello students. Now in this lecture we will start discussion from unit number 4. Then what is the topic is input output instruction. So first we have to understand what is input instruction and what is output instruction. Input instruction is an instruction which is used to input information from the user is known as the input instruction. Means if you want to perform some task, that means you have to give some input for getting some output. So this is the input thing. And what is output instruction? An instruction which is used to give some output. Or for example, when you want to print something on screen, so you use instruction which is used to print something on screen, or any other output device is known as the output instruction. So this is the input instruction and output instruction definition. So what is the definition of input? An instruction which is used to input information from the user is known as the input instruction. And what is output instruction? An instruction which is used to print something on the screen or any other output device is known as the output instruction. Now in this chapter basically present the input output features of the 80386 from the following perspective. Instruction. So this chapter present the input output features of the 80386 from the following perspective like that. First one is method of addressing input output ports. Second one, instruction that cause input output operation. And third one is protection and input output address, means protection as it applied to the use of input output instruction and input output port addresses. Means what does that mean? Means we cannot use input output instruction directly. We have to use some protection mechanism before using input output instruction. So this is the protection feature basically provided by the 80386 processor for using instructions. We cannot use any instruction without checking privilege level. Some instruction we can use it, like move instruction for data transfer, like arithmetic instructions like addition, subtraction, multiplication. These instructions we can use without privilege checking, but some instructions are privilege sensitive, means we have to check the privilege level of these instructions before executing or before using it. Without checking privilege level we cannot use these type of instruction. So input output instruction basically comes under this category. So we have to use these instruction. First we have to check the privilege level. Now what is input output addressing? The 80386 allow input output to be performed in either of two ways. First one, by means of separate input output address space using a specific input output instruction, and second one is by means of memory mapped input output by using a general purpose operands, general purpose manipulation instructions, etc. So the 80386 provide a separate input output address space distinct from the physical memory. What does that mean? Means whenever if you have a memory block and when you divided your memory block into segments, you know very well your segmentation mechanism. Why we are using segmentation mechanism? So we can properly utilize the memory space. So that's why we divided our memory space into different segments. Then it depends on the application, depends on the processor features. Your segment size may be fixed or may be variable. So 80386, because we are discussing 80386 processor, so in this processor the segment size is variable size. We have discussed this point in first unit. Your segment size can be vary from 1 byte to 4 GB because your processor memory, physical memory is 4 gigabyte. So your segment size can be varied from minimum size is 1 byte and maximum size can be 4 gigabyte. So we divide our memory into segments. Why? Because we can utilize proper memory space. And in that case, your segment basically you assign to different applications. Now in that case, your input output addressing mechanism, you define a different segment. You assign a particular segment or different segment to a input output address space. So the first point is by means of a separate input output address space means you define a different memory segment for particularly input output address space. Or in a second method, by means of a memory mapped input output means you are not assigning a different space to the input output instruction, but you are using a same address space for the input output instruction or for the other instructions. Means you are not assigning a different location or different segment for the input output instruction. So these are the two way for addressing input output instruction. First one is the separate IO address space and second one is the memory mapped. In a IO address space, separate IO address space means you are assigning a different segment for the input output instructions, or in a memory mapped means you are not assigning a different address space, even you are utilizing a same memory space. So what is IO address space? The 80386 provide a separate IO address space distinct from physical memory, just like we have discussed in earlier point. Second one, the IO address space consists of to the power 16, 64K individually addressable 8-bit port. Any two consecutive 8-bit port can be treated as a 16-bit port and 4 consecutive 8-bit port can be treated as a 32-bit port. What does that mean? Means your port size is 8-bit. If you wanted to transfer 8-bit data, so in that case you will use 8-bit port. If you wanted to transfer 16-bit data, in that case you will use 16-bit port. And if you wanted to transfer 32-bit instruction or 32-bit data, in that case you will use a 32-bit port. What does that mean? Means your port size is 8-bit, but if you wanted to transfer 8-bit data, in that case you will use individual 8-bit port. But if you want to transfer 16-bit data, in that case you will combine two consecutive ports. So your 8-bit port plus 8-bit port, this will treat like a 16-bit port. If you wanted to transfer 32-bit data, in that case you will combine 4 consecutive ports because your port size is 8-bit. So 4 8-bit port will make a 32-bit port. So if you want to transfer a 32-bit data, in that case you will combine 4 consecutive 8-bit port, right? Because your processor is a 32-bit processor, so at a time you can transfer 32-bit instruction, 32-bit type instruction you can transfer at a time. If your processor is a 16-bit processor, that means you can execute a 16-bit instruction or you can transfer a 16-bit data. More than that you cannot transfer this. So it depends on your processor size. Okay, what is your processor size? According to that you can transfer data. If you have a 32-bit processor, that means maximum instruction that you can transfer is 32-bit size. If you have a 16-bit processor, that means 16-bit data you can transfer at a time. 16-bit instruction you can execute at a time. So this is the meaning of this point. The input output address space consists of to the power 16 means total number of 64K ports if you have a 8-bit port. If you combine these two ports, means if you wanted to transfer 16-bit data, means you will combine two consecutive ports, so they will be treated like a 16-bit port. Or if you combine 4 consecutive 8-bit ports, so it will be treated like a 32-bit port, like that. Thus, the input output address space can accommodate it up to 64K 8-bit port up to 32K 16-bit ports or up to 16K 32-bit ports. Means if you have a 8-bit ports, so your total number of ports is 64K. If you are using ports as a 16-bit port, in that case your total number of ports is 32K. If you are using your port as a 32-bit port, in that case your total number of port is 16K. The address of the port can be specified in two ways. First one is immediate byte constant and second one is using a value in DX. Means what is that meaning? First point is 256 8-bit port number from 0 through 255. Second one is 128 16-bit port number from 0 to 4 to 254, and 64 port, if you have a 32-bit ports, then total number of port is 64, number from 0 to 252. What does that mean? Immediate byte transfer means from your port you can directly transfer the data to any general purpose register by using a 8-bit port, by using a 16-bit port or by using a 32-bit port. And second one is using a value in DX, means in that case you are using a DX register as an intermediator. First you have to transfer the value from port to DX register, then DX register to any general purpose register. So in that case we can say that you are using a DX as a intermediator. Now second type input output instruction is memory mapped input output instruction. By placing input output devices memory address space. Memory mapped input output provide additional programming flexibility. Any instruction that references memory may be used to access an input output port located in the memory space. And memory mapped input output, like any other memory references, is subject to access, protection and control when executing in protected mode. So what does that mean? Means you don't have a different memory space for the input output instruction. Basically you are not assigning a different segment to input output instruction. You are using a same memory space for the input output instruction in that case. So it will provide additional programming flexibility, means your time is less when you are accessing the input output instruction. And third one is any instruction that reference memory may be used to access an input output port located in the memory space. For example, move instruction. Move instruction you can use to transfer the data from register to memory, from memory to register, from memory to from any immediate value to memory, from any immediate value to register. So just like that, move instruction is a memory mapped instruction, means you can directly use the move instruction for transferring the data. But if you are using a input output address space, in that case you cannot use any instruction without checking a privilege level. That doesn't mean we are not performing a protection mechanism in a memory mapped input output base, because we are performing a protection mechanism in a different way in both techniques, means input output address space or memory mapped input output address space. We are providing a protection mechanism but in a different way. So in a memory mapped input output address space, we are providing a protection mechanism like we will check current privilege level, request privilege level field and descriptor privilege level field for checking the privilege level. For example, if some process want to access the input output privilege